we are presenting our project for the MLOps, which is cats versus dogs classification. Here I'm presenting end-to-end architecture that we followed in this project. Here in our project directory, we have added the folders. The first one is the data. In that, we have downloaded the data from the Kaggle dataset, and it's there are the two classes, cats and the dogs. So it's mentioned it's here. So train class and the train folder and test folder same we use for the validation. So after the data, there is another folder which is the logs. Here we are maintaining all the logs whichever are getting stored while running this application. After that, we are having this folder. In that we are storing the metrics. In that confusion metrics for this results we are storing here, how much accuracy it's giving on the test data set. After that, ML runs. Here in the ML runs folder, as we are running the experiments using the ML flow, so all these experiments are getting tracked and monitored inside this folder. After that, we have the models folder. So once we completed the training, the final file, which is the PT file that we are storing inside this, and the same file which we are using for the final deployment purpose. After that, whatever we are running, so all the scripts are here we have automated using the setup part, and this code is written inside the source. So whatever code we have written for the pre-processing part, inference part, model training part, so all the code files are mentioned here. Okay. After that, test script we have written inside this folder. So all these test scripts are here. So this is our folder structure, and apart from that, we have also created the Docker file. After that, GitHub Actions file. So all these files we have stored here. Using that, all these pipelines are getting executed. So let me start with the first part, which is the uh, environment creation. So here we have created the dedicated environment for this project, and that environment we have created using this requirements file. So this is the first step that we followed. After that, uh, let me move to the DVC data version control. So here we are maintaining the data versions using this DVC, and all the information here we can see that we are storing here. After that, I will show you the status of our DVC. Okay, so this is the status for our DVC, whatever we are storing. Next step is the activation of the environment, and inside this we started the model training. As in the model training part, first step is the pre-processing. So all the pre-processing steps and everything. Okay, our next part is training the model. So while for the training purpose, we have used the ML flow. So I will show you ML flow dashboard of our project. So this is the command ML flow UI. So using that, it will start this survey. Let me navigate to the UI. So here we can see that this is our ML flow tracking platform that we can track our model. So this is the model which we trained last time. So all the artifacts related to this model are stored here inside this. So we can track and monitor the process, also maintain the different versions of this model using this ML flow. After this ML flow, our next part is the inferencing. For the inferencing purpose, we have used the fast API. Using fast API, we have created the endpoints. Mainly, we have created the three endpoints. In that, first one is the health check. In that, we are checking the health of our application. Okay. After that, second one is the normal inferencing. In that, we are calling the model so that we can predict our images live. So this is the second one, which is the predict, and third one is the metrics. So these are the three major endpoints which we have created. So let me show you one by one. Here in the health endpoint, we can simply execute this and check how is the health of our model. So as it's running fine, so that's why it's showing the healthy as its status. So next endpoint is the predict. Inside the predict endpoint, let me try here and choose some file from my system. So this is a random image which I took. Okay, and once I click on the execute, so see it's showing the result as a cat. So also we can see the confidence, how much is the confidence level. So we can see that 86% confidence level it's showing, and for the cat how much it is the confidence level, and for the dog how much it's confidence level. So that all information we can see here. Next step after this. Okay, so this is the predict endpoint, and after that a third one is the metrics. So inside this matrix we can check how much latency it took. After that, a few other parameters which we are storing. So all these things we can check here inside this metrics endpoint. Okay. The next part is the Docker file creation. So here we have created the sample Docker file, and using this we have created the image, and that image we are running inside this our Docker container. Let me show you. So this is our Docker. Inside this we have created the a Docker image which we are using for the Kubernetes cluster to make it in the form of the service which we can consume using the endpoint API endpoint of the fast API. So this is how we have created the Docker. The next part is we can also track the logs of this Docker file using here. See whatever is getting executed. So all these logs we can see here inside this terminal. The next part is the CI/CD, which we have maintained inside this code base. So whenever there is a new code is getting pushed to the repo, so at that time automatically CI/CD will start the execution, and the after the execution, the new model will get applied to our final store, so that a new model will get consumed for the subsequent API request. After that, after creation of the Docker file, the last part remaining, which is the deploying it to the Kubernetes. So for the Kubernetes, uh, we deployed this application end-to-end process to the Kubernetes. And let me show you the status of our Kubernetes, and also I will show you the Argo CD, which will showcase these models live working there. So here we can check the health status of our Kubernetes pod. And after that, let me show you the Argo CD dashboard of our Kubernetes pod, how it's working. So this is the Argo CD UI, and here this is our application cats versus dog classifier. Once we go inside this pod, here we can check this classifier which is working. So all these things we can track here, how our pod is working, status of this pod, is it a healthy or stop. After that, we can also check the logs of this Kubernetes pod, how it's working. So all these things we can track here inside this Kubernetes Argo CD platform. So this is our end-to-end project. Here we have covered starting from the downloading the data. After that, training the machine learning model. Once we train, after that, managing the different versions of the machine learning model using this MLflow platform. After that, we have created the Docker image, and after creation of the Docker image, we deployed it using the Kubernetes to make it available in the multiple regions. So this is how we have created the end-to-end application. Thank you.